Okay. All right. So, any questions, comments, complaints? Write your complaints on a Post-it, and yeah, no. Okay. So, going to finish talking about exceptions, and then there's the book had this. It's not something that I use a lot really, but it's actually a very convenient situation. This optional thing, and then the final topic today are object wrappers. The book has a section on it somewhere in a different chapter. I'm not sure where. It doesn't really go into it in too much detail, but that's going to be an important thing to understand when we move into our next topic, which is going to be dealing with the collections framework and what that's all about. You'll read all about that in the next chapter that I'm having you read. The book has a chapter on unit testing, and I wish I had time to cover that a little more here, because that's an extremely valuable thing, especially if you're dealing with larger applications. In fact, there's a whole cult around that about test-driven development and stuff like that. It had a big splash a few years ago. I'm not sure how it was kind of cultish in a way, but like many of these things that kind of come out, it's like they come out, they solve a huge problem, and then all of a sudden it becomes the next big thing, and then of course it becomes overhyped because it's going to solve all of your problems, and then with experience you discover no, it doesn't solve all our problems, and so then a lot of times it gets thrown out like the baby with the bathwater type of thing, and yet there is often nuggets of things that are really important. So just if you're involved with any kind of programming project, and the thing is that the chances are most of you won't necessarily be kind of the lead programmer on a big project. Usually it's with a team of things, and maybe you'll be more managing it than actually writing the code. But nevertheless, when I work with sponsors, the ones who have done at least some coding it tends to be much more effective because they have a deeper understanding of kind of how the process actually works, and that's an important thing. Anyway, this unit testing is something that's really valuable, because it gets back to one of the things that I have been harping on, which is editing. Editing is sort of a very risky thing. Once you have a code that does something, anytime you edit it, you could either make it better or you could make it worse, and half the time you make it worse. So how do you know if you make it worse? So imagine a project that it has literally hundreds, if not thousands, of classes running around, and you start making changes. If you think about how these object-oriented programs work, you have all these objects running around sending messages to each other. So if you make a change over here, it could affect a lot of different things. So what unit testing does, and it's kind of a low-level thing. There are other ways of testing, like regression tests. But so I've fixed the bug. Say somebody says, okay, here's this problem. So I go and I fix it over here, like surgery, no trivial edits. Have I broken anything anywhere? So what these unit tests provide is just one. Imagine having to go through every class and sort of saying, did it break this? Did it break that? With these unit testing framework in place, and it requires extra stuff that you've written. But with that in place, then you basically hit one big easy button, and it goes through and just sort of tests everything, and then all of a sudden things that have broken inadvertently through this edit, kind of come back. So that's that's an important topic, but it's kind of a little more advanced. So we're going to have to skip over it. I was very pleased to see that the book kind of covered that, but that's and if you're particularly if you're kind of a programming nerd like myself, then it's something to kind of look into if you haven't already. Anyway, back to exceptions. So we've covered the basics, so we have errors and exceptions. Errors are things you can't really control so much. I mean, exceptions are things that you have to deal with in the program. There are things that can go wrong at runtime, and so there are runtime exceptions which are unchecked, and then there are the checked exceptions which have to be explicitly either tried or caught and whatever. So as you, when you're writing stuff that many different things can go wrong, different exceptions can be thrown, you're often in a situation where in a block of code, there are a number of different exceptions that could be thrown. And so you have this kind of situation where you have to catch this one and catch that one and catch the other one. And so that's where this multi-catch idea comes in. So it got to be really kind of messy. If you have a block of code that could throw a number of different exceptions, then you can actually sort of in one line just kind of catch them all. In other words, once an exception in a try-catch block, once that exception gets thrown, even if another exception would have been thrown later on, you won't even reach that. Because when you throw an exception, you bounce out of the next line execution and you go to the catch statement. So, so then after a little while and probably after a lot of complaining, they came up with instead of a series of these catch blocks, you can declare a multi-catch, which is if you have a number of different exceptions that could be thrown, you can sort of stack them up in that one catch exception. And then typically in what you do in the catch block there, you need to sort of say, okay, which exception actually did get thrown and what do you do with it? When it comes to catching and maybe rethrowing exceptions, as you've seen, but I need to kind of point out, any uncaught exception of any type, if it never gets caught and dealt with, it will bubble all the way up to your main method, and if it is not caught by the main method, then the program kind of bombs out, and you get those you get red and the green and the blue kind of things that say basically where it is. And sometimes that's the thing that you want to do in larger. Ideally, though, the user-friendly thing to do is to make sure all of that gets put in the log file. Now we haven't. At some point, I'll show you how to use those logging statements to put them into a file, and that's because, I mean, here's what happens. So for the like for when NavSub kind of runs something and they say, hey, we ran it and we got this error. So send me the log file. So the log file will have all that information that we've been seeing in the console. But okay. So, but here we are with the multi-catch. So there's if you kind of do a pull on the class code. Okay, here's just how to test it. So, what kind of situation might we have? Well, you're kind of invoking methods on objects that could throw exceptions, and that's what the situation is. I wanted to illustrate the multi-catch here, but instead of kind of coming up with everything, what I'm doing is that I'm explicitly throwing stuff. So here what I'm doing, I create a random thing, and then I'm going to generate an integer from 0 to 2. And then depending on what value it is, I'm just going to throw one of these different exceptions. So here's an arithmetic exception, a legal argument exception, a null pointer exception, and then here's how the multi-catch works. So here, because each of these 3 exceptions could be thrown, then I'm going to catch, I catch them all, kind of like the Pokemon of exceptions, and then and now here what I'm going to do here is I'm going to rethrow it. So there's, when you catch an exception, you have one of 2 choices. If you don't rethrow it, then it's like, okay, what has happened can the program continue? In almost all cases, the program really can't continue. So so in this case, I'm going to throw it, and then if there was a calling method for this, then they would have to kind of deal with that. In this particular case, it's just going to bubble all the way up to the top, and kind of bomb out the program. So that. But if I don't do that, then it won't. We can kind of see how that goes. All right. So if I run this multiple, each time I run it, I'm going to get a different outcome. What are you doing here? All right, let's look at it here. So here, okay, I was inside, and I'm logging kind of where I am. So here I'm inside the try, I'm inside the catch, and then notice I'm inside the finally. So the finally, it's usually important to have a finally, because if something wonky happens, and if I don't have a finally, then I have no control here about what happens. So with the finally will always execute even if the exception gets thrown. So that was so here what okay, this was an illegal argument exception. If I run it again, it might be a different one. Okay, there was an arithmetic exception. I run it again, etc. Now, so in this case, it was kind of bombing all the way out. Ideally, though, what I would want to actually do is put this in the log file and kind of not have it bubble all the way out to the top. But this would be a situation where if I was somewhere deeper in the program and there was a call, I wanted the place that called it to have some sense of kind of what happened and what went wrong. Here I'm in the main, so it's kind of like that. Anyway, but point of this is if I have multiple exceptions, I can do a multi-catch and kind of basically catch them all. Now this comes up a bit, like there are in almost every one of the situations that I've been, whether it was writing a simulation library or writing a larger program, most of the time the exceptions that exist in Java are enough. And one of the nice things, one of the things I thought they did particularly well is the names of the exceptions are self-documenting. And you want to be so if an array index out of bounds exception, I mean, that the only missing information on that is what index was out of bounds. Was it like a negative one, or was it out of the, it was either a negative for any array. It was either a negative value or one that was the index, the length of the array, which is not a legitimate index, or greater. So that's the only thing I would. Null pointer exception, again, that once you understand that it's actually not a null pointer, it's actually a null reference. But but the point is there is only one circumstance under which you get a null pointer exception. If you have followed the prime directive of no public instance variables, In that case, the only way to get a null pointer exception is by invoking an instance method on a object reference which has not been instantiated. That is the only thing, the only way that that can occur. And that is why the null pointer exception is your friend, because when that happens, you know exactly what's gone wrong and you know exactly where it is. And so you know exactly what the problem is, which is, here's an object reference that the code, when the code thought, the intent was that this be an actual object, because if it doesn't make sense to have to invoke a method on a null thing. And so so why did you think that this would be instantiated? Okay, so somewhere there must have been a new thing that was missing or whatever, and so you just kind of in other words, you just kind of start following the breadcrumb trail of why this object was null when I thought it was instantiated. And there are some little gotchas that can sort of happen. However, every now and then there's a case for where you want to where something goes wrong in your program and it doesn't fit easily into something that Java has been named. So, for example, in my simulation package, there were things that had to do with for example, if the simulation attempted to reverse time, that was something that could happen, and it was something that how should I say, if we're trying to model actual real things. So far, movies are the only and novels are the only place where time travel has actually been instantiated. So until they have an actual sort of time machine, then attempting to reverse time in a simulation is going to be an error. Java does not have a attempt to reverse time exception. So in that, I wrote an exception that says, attempt to, I forget the exact name, but it was like, attempt to go back in time exception, something like that. And so sometimes, if you're writing something, you can define a custom exception. One of the powers of the way that Java has set things up with their class hierarchy is that it's really, it's very easy to do that. You don't have to, there's only a couple of things that you have to do. So let me just sort of give this is going to be a silly example, but let's, okay, so I'm going to define an exception called my stupid exception. Let me do it again. And I just define a new class, which is Java class. Exception, and yeah, and you by convention, exception is sort of the last thing, and so you want to say here's what went wrong, and exception is thing, and now generally you want to either subclass exception or subclass runtime exception. If you want it to be checked, then subclass exception. If you want it to be unchecked, meaning it could just sort of happen, you could subclass runtime exception. So let's subclass exception. Now, basically all you need to do is write 4 constructors. That's all. So you want a 0 parameter constructor. And each one just calls super. This is the exception to what. Okay, the first one is a 0 argument. The second one just has a string that's the message. That's the most common one, which is when it gets thrown, you want to say, okay, here's actually what went wrong. Then the other 2 have a constructor that has a throwable, And what that does is that when you a lot of times when you catch one exception, you can kind of rethrow it. And all you need to do is just pass it to the constructor of the one that you're instantiating. So I may catch one exception and then throw it as another. In fact, that's kind of what I did here. Notice that when I caught whatever exception it was, I threw a new runtime exception, and I just passed the exception to it. And what that did was it had all the information of that exception, but now embedded in another exception. And so I need that's where this constructor is. And then there's yet a fourth, which is a message and a cause. So, and that's all you need to do, and then, of course, comment it or whatever. So that's about as easy as anything. I mean, there's no logic, all of the mechanisms for dealing with exceptions are already in there. And so, just to kind of illustrate it, let me add it to my little example here. And let's, what did I say? And let's, oops. Oops. Okay, so now I've kind of added it to mine, and now I get a red squiggly. And what does it say? It says unreported exception. Okay, why does it say that? If I had subclass runtime exception, it wouldn't do this, because an unchecked exception just says, okay, you don't have to deal with it. And then does it have a suggestion? Okay, so suggestion is add a catch clause. And then, okay, so I don't want to add a catch clause. I want to add it to my multi-catch. So let's add it here. Oops, spell it right. Okay, so now it's catching all of them, because it was an exception, not a runtime exception. I have to explicitly catch it. And so now, let's see, that was a null pointer. I need to run this a few times. Illegal argument.
Sir, aren't you randomizing between 0 and 2? Oh, no, you changed it.
Yeah, I changed it. Yeah, thanks. Yeah, there we go. There, I got one. Yeah, so you can see, and the other thing is that notice that these arithmetic exception, illegal argument, and null pointer exception, I think were all runtime exceptions, or unchecked, and this was checked. So you don't have to, you can mix and match those. Okay, so that's creating your custom exception. Yeah, so there's the zero argument, the string argument, throwable, and string throwable, and all you do is call super. So it's like easy peasy. And what that allows you to do is now just have a finer way of telling the user if something went wrong. My use cases are all situations where I'm doing something a little different that isn't covered by one of the standard ones, like the attempt to reverse time and other types of things. So, and things like that come up. I mean, now these null pointer exceptions are, and they're also because programmers like the military loves acronyms. If you see NPE, that usually stands for null pointer exception, at least in this context. So they can be annoying and tedious, especially if the main use case here is if you have an object that has instance variables, and some of them are optional. Now, there are a couple of ways of dealing with that. The most straightforward is that you have sort of default values that get set to the thing, but maybe you don't want to do that. And the books has a nice use case example where we have a class and we have separate instance variables for the first name, last name, and middle name. But not everybody has a middle name for some reason. So the middle name could be null. And so you want a situation where, now, one way of dealing with that is to say, well, if you don't assign a value to the middle name, then we'll give it a default value, like an empty string, something like that. But that can be a little fragile. So this idea of an optional variable is a very useful one. So where is it? Okay, so here's the and this is a throwaway thing. So I actually put a main method in here just because I didn't want to notice that we have a whole boatload of classes here. I didn't want to kind of clutter things up too much. Okay, so here's here you have an employee, so last name, first name, and then the middle name. And the thing is, the middle name may or may not be there. And I know that they're used to, what was it? If you didn't have a middle initial, it would say NMI. I don't know if they still do that, but anyway. But if they don't have one, it's going to be null. And so here's what you do is you declare it this way. Instead of, it's going to be a string, but instead we're going to declare it to be this other class called optional, which is a kind of what's nice about that is it's fairly descriptive in that it's saying this is going to be an optional thing. So in other words, it could be null. Now notice the strange syntax here. We have these angle brackets and we have string in there. So what that says is that this variable, this is going to be, first of all, optional. And then second of all, when it's there, it's going to be a string. And we could give it, actually, we could put any class here. Here it happens to be string, but it could be any class, whether in Java or a user-defined one. Okay, so here it's like, okay, we have a master constructor with all three, and then we have one that just has the last name and the first name. So that's kind of kind of why do it this way? Well, because if I have somebody who doesn't have a middle name, then this is the way I'm going to do it. And what I'm going to do is I'm going to set the middle name to null. Okay, so and that's always a kind of a dangerous thing. Now here all the setters and getters are straightforward except for the middle name. So let's look at kind of how they differ. Okay, first of all, remember middle name now it's not a string. It's what the type is actually this optional class. It's a type of optional, but it's been sort of parameterized by string. So it's going to be an optional string. And the way to to set it, in this case, is that if it could be null, you say optional of nullable here. So notice that I'm passing a string. This is a string, and I'm passing that string to this method here, which isn't a normal constructor. This is actually a static method. Okay, how do I know it's a static method? Because I'm invoking it on a class, not an object. So that's, you know, how, if you're looking at code, how can you tell if something is a static method or an instance method? If I'm invoking it on an object, then it's an instance method. If I'm invoking it on a class, it's a static method. Okay, so what this says, now if I say it's of nullable, that says it's gonna give me a null. So underneath, and where it's storing that string somewhere, it's gonna be null. But then what happens if I try to get it? Well, there's an instance method, and it's an instance method because I'm invoking it on an object. And this says, on this optional class instance, either return the actual string that's in there, or, in this case, return the empty string. So this will always return a string, but if it's null, it's going to return the empty string. And what's nice about this is that this is a much cleaner way of doing things. What's the option if I don't do this? If I don't do this, then and I want the same effect, I would have to say something like, okay, if it's not null, return the value, otherwise return the empty string. That would have exactly the same effect. Not a big deal, but this to me shows the programmer's intent much more cleanly. But your mileage may vary. So because this is kind of a throwaway, now normally, don't try this at home, as it were, but because this is a class example, it's just a throwaway. It isn't something that I would use for any other program. So I put the main method in it, and now I'm just going to create a bunch of employees, some of which have a middle name, some of which don't. And then now I just kind of print them out. And by the by, in my toString, this is an example of that formatting that I talked about yesterday. And this to me is also a lot cleaner and easier to deal with than kind of trying to concatenate strings, which you'd have to do if otherwise. So here I'm formatting, okay, string, comma, string, string. I'm going to have last name, first name, and then middle name. And I need to make sure I'm getting the, I use the getters for these. Okay, so if I run this, then, okay, so here I get my my people there. So the ones that have a middle name get it there, and the ones that don't show there. So, okay. So that's a useful little thing to have. So finally, yeah. So we declare it using this, and when we start talking about collections, this is gonna come up. This is something called generic, and it's a way of declaring classes that could have any one of a number of different classes on the inside. In other words, this optional class can take any class whatsoever and deal with it in the same way. And you specify it by this. It makes it's type safe. So for example, if I was trying to do this with if I try to do something other than a string on the one I declared a string, the compiler won't let it. So it's a way of type safety and maximum flexibility. We'll see that when we, in collections, that becomes a big deal. Now, in preparation, this is actually sort of in preparation for that, it's important to understand what these object wrappers are. And what see, Java is not a pure object-oriented language. In a pure object-oriented language, the only things that exist are objects. And so if I'm representing numbers in a pure object-oriented language, every number is an object. First of all, that can lead to, if I'm doing a lot of computational things, that can make it really, really slow. And second, that depending on how tightly I've wrapped the objects, you can do some weird stuff if you extend things. So Java is not a pure object-oriented language. The other thing is that they were trying to pull in C and C++ programmers, and C and C++ have both primitive, well, C++ has both primitive and objects. C is just a pure procedural language. Actually, C is actually, C is not a high-level language. It's a high-level assembly language. C was invented to write operating systems on, not high, so that's why all these other things exist. The other thing is that depending on which online forums you might visit, or I guess they still have this sort of argument about, well, C++ is faster than Java, C++ is better, Java's better, The thing to understand, though, is that when Java came out in the mid-90s, C++ was by far the dominant object-oriented language. If you wanted to implement an object-oriented program it wasn't, there were other, there were languages like, well, Smalltalk was kind of like the granddaddy of a lot of these. There were other object-oriented languages. C++ was the dominant one. And then Java came along, and then within a few years, Java became the dominant language. And even today, Java, there are more Java programmers than C++ programmers. I don't know if Python has kind of overcome Java yet. If not, it will soon. But the thing to ask is that if C++ were really better than Java, and it was definitely faster when it came out, why was Java able to get any market share at all? If C++ was better and faster. So I mean, if you're kind of looking to do something, there must have been something about Java that caused people to say, okay, I'm going to switch. So anyway. All right, so okay, sometimes my ADD kind of comes swirl. Okay. All right. Java has two types of variables, so it's not a pure object-oriented language. It has primitives and it has objects. If it were pure, it would only have objects. But it has these ints and doubles. And now it turns out that when what happened was, in order to have a rich set of data structures to kind of do business with, in a way that's also type safe, then it turned out that using that generic idea that was over here was the way that they went. And the thing about that is that what they basically needed to do was have an object representation of each of the different primitives. And that's what they have. So in some contexts, you need an object to represent a number. And we're going to see that out the wazoo once we start talking about collections. So actually, right from the beginning, Java provided a wrapper class for each primitive. So, and this is, well, this is the class hierarchy. So remember, object is the granddaddy of them all. And then it has three immediate subclasses: number, Boolean, and character. Number, notice, is abstract. So Boolean, the Boolean object with a capital B, Boolean class with a capital B, it corresponds with the Boolean primitive, lowercase b. The class character with a capital C corresponds to the primitive char. And then all the other ones are actual numbers. So what are the different numbers? Bytes, shorts, integers, longs, floats, doubles. Longs, doubles, and integers are really the only ones that we deal with. As I said, floats are just not, don't have enough precision to do the kind of calculations that, if you're doing, if you're writing an application with calculations in it, floats do not have enough precision to give you the right answer. Doubles don't give you the right answer, but it's much closer. Okay, so the byte capital B corresponds to a byte lowercase b. Integer capital I corresponds with an int. Long capital L corresponds with a primitive long. Double capital D corresponds with lowercase d. And then when they first came out, it was actually sort of a bit of a pain because these are objects. What would happen if I reach a point where, for whatever reason, I have numbers that are these object wrappers, and what if I want to do a calculation on them? Well, when they first came out, they had each of these. So, for example, double had something called a double value, and so I had to kind of unwrap it, do the calculation, and then oftentimes kind of put it back in another one. And so that got to be a real pain. Everybody kind of complained about it, and so they came up with this idea of autoboxing. And so what it'll do is autoboxing, it'll convert an object wrapper to its primitive value if it's in context. So if I take two object wrappers and I add them together, if I have a statement to add them together, Java realizes, oh, you're trying to add these two things. So under the hood, I'll unwrap them, do the calculation, and then assign it to a variable which is either a primitive or an object wrapper, and do that for you. And likewise, if I am in a situation where I'm doing a calculation and I want to put it into an object wrapper in context, then it will do it under the hood for me. So it'll kind of look like I'm doing that. Now, as we'll see when we get to the collections, when we define our collection objects, and we will specify what type of number is going to be in them, we cannot put a primitive in. We have to put an object in. And let's see, I think I have an example of that. I do. There it is. Okay. So just here's an example. And here I'm kind of mixing and matching. So here is I'm going to declare x to be an integer object wrapper and y to be just a primitive int. But now look here. X equal 4. Now syntactically this is totally illogical. Why? X is an object. 4 is a number. So what the heck? Well, that's where under the hood Java's saying, oh, you're trying to assign a number to an object wrapper. It's consistent, so under the hood, I'm going to take this primitive number, wrap it up in an integer object, and assign that integer object to x. Okay, y is just sort of a primitive, but now, okay, so over here, I want to print out x plus y. So this is an object plus an int. Syntactically, it's nonsense. Syntactically, it makes no sense whatsoever. But logically, you say, well, okay, this this is really, under the hood that it's representing a number. I'm not trying to add it to a number, and so under the hood, what it does here is it says, oh, you're trying to add an object wrapper to a primitive, and so I'll unwrap it for you, and then do the computation. Here I'm printing it as a primitive, so the value of this expression is going to be the primitive. And this will also work if I have okay, so here's yet another object. Let me if I just add two of them together, okay, so here now I'm adding two integer objects together, and it sees the plus, and again, that makes it is totally syntactically is nonsense, because you can't add objects together. I mean, that doesn't exist. But Java realizes I'm trying to add two object wrappers together. They're compatible, and so under the hood, it's going to unwrap them and then rewrap them, and then hopefully do everything right. And then furthermore, let's just sort of print this. Okay, here I'm doing yet even more. So here's an integer object. I'm adding to another integer object, and then assigning it to another integer object. Again, syntactically, this is nonsense. But, okay, so what does it do? On the right-hand side, it says, okay, here's an expression which I can make sense of by, unboxing is the term. So I'm going to unbox x to its primitive value, unbox z to its primitive value, add them together, I get a primitive, the result of this expression is a primitive value. But then I'm going to assign it to an object wrapper, which again is nonsense, because this is an object, this is a number. Doesn't make sense, but it says, okay, I'm trying to assign a number to an object wrapper, and so under the hood, I'm going to now rewrap the whole thing and put it into this object here. And now I'm going to print it as a number. And so here in this print statement, it takes this integer wrapper, it unwraps it to its primitive value, and then does the print. So there's a lot of stuff happening under the hood, but the bottom line now is that I can at least take these object wrappers and manipulate them in a, as if they were the primitives. So when I'm defining my collections, I've said that name, and you'll read about it, and we'll start talking about it on Monday. In those collections, I can only put, if I want to have a collection of ints, of integer values, I can only use the object wrapper. I cannot create one of these with the primitive int in it. Can't do it. Why? Because of the way that these generics are set up. So this is important to kind of understand. And with the auto boxing, though, it's like I can now, I don't have to do a lot of contortions and twist the code into a pretzel. Before they introduced auto boxing, I had to, let's say I had a bunch of these integers in one of my collections, and if I got it out and I wanted to do something with it, I had to unwrap it. And then if I wanted to put it back, I had to rewrap it and do all that. And then finally, they said, okay, that wrapping and unwrapping is you can always figure that out in context, just as it was done here. So I can figure out that if I'm trying to assign a number to an integer wrapper, and I'm trying to assign an integer under the hood, it just wraps it. And if I'm trying to add them together, I can just unwrap them. And if I'm trying to then assign it to another object, I can just rewrap it. So that's what's happening under the hood. Okay, so we're gonna jump over chapter 11, which is the unit testing thing. Again, something for the interested student or to kind of look at. They have a section on the legacy classes. When they first came out with it, they had some classes. They were kind of funky. It turned out they were not all that great. They're still around for backwards compatibility. The book kind of mentions them. We're not going to cover them. You're not responsible for them. You shouldn't use them. But we're going to start talking about collections. We're going to spend some time on this because this is a really important topic. And it's one actually back in the day before they had libraries like this, you'd have to roll all of these on your own. So we're done here.